We'd like to welcome you to the video tutorial for the Sinumeric 828D CNC. In this tutorial, you'll learn more about programming with the Machining Plan Editor. You'll learn about the programming cycles and the geometry processor for creating contours, and see how easily it can be programmed on the front panel. With a simple example workpiece with contours, pockets and holes, you'll create a Shopturn program based on the drawing. First, change to the Program Manager to create a new Shopturn program. In the new Shopturn program, specify general parameters such as the dimension unit and the raw part in the program header. Typical raw part forms are pre-selected, and you need only enter the dimensions of the workpiece. Static and animated help pictures provide support with the parameterization. Press the Accept button to save the inputs. The program is divided into work steps. In the example, you see the program header and the end of the program. In between, work steps such as turning machinings or traverse movements can be created. To do this, use the horizontal and vertical soft key bars. We first show how simple the face turning is. To do this, select the Turning and then Stock Removal soft keys. The dialogues for programming a work step have a similar structure. The required tool is first selected from the tool list. Then enter the cutting parameters. Depending on the machining, various parameters can now be selected. These include, for example, whether rough cutting or finish machining is to be performed. The end face should only be rough cut. Self-explanatory help pictures provide support for the input of the geometric data. Press the Accept button to transfer the work step to the program. The stock removal work step has been completed and is displayed as a marked line. You can reopen and change the work step at any time. As the next step, we use the integrated geometry processor or contour computer to create the turned part contour. This consists of a raw part contour, as can exist for cast unmachined parts for example, and a final contour. To create the contour, select Contour Turning and then New Contour. Specify the name and the starting point. You can now use the vertical soft key bar to create various geometric elements, such as straight lines and circle segments. For example, you see how first a straight line in X and then a straight line in Z are created. The complete contour is then formed from the individual geometric elements. Once the raw part contour is complete, create a new contour for the final contour. This is also processed with the geometry processor. In the broken line graphic, you now see the raw part and the final contour. During the stock removal, Shopturn takes account of the raw part contour and no blank steps are travelled. For turning the contour, we use the cycles for contour turning. The contour is first rough cut. You parameterize the cycle as shown and select roughing as machining item. Help pictures simplify the parameterization. For the complete machining of the contour, a special cycle for residual material rough cuts the final contour. The contour is then finish machined. The cycles for contour turning are all chained with the contour. This is represented as parentheses in the work plan. You now see the work plan of the complete workpiece. The work steps for the tapping and the end face machining with pocket are now milled and drilled holes added. We'll shortly present the subsequent process. Shopturn has many different pre-configured undercut and groove forms. We select and parameterize a thread undercut. We create the M48 external thread with the thread cycle. Specify the external diameter and the pitch. You can change other specific parameters, such as the feed. The normal cycles for milling and drilling can be used for the subsequent end face machining. In the milling cycle for the rectangular pocket, you can specify whether a face or peripheral surface should be machined. You select face, and Shopturn converts the programmed position on the end face. As with the contour, positions can be chained with machining operations. In this case, these are the drilling and tapping in the whole circle positions. In the next work step, the drilled holes are set and the thread tapped. In the drilling and tapping cycles, select as usual the tool and enter the parameters. For drilling and tapping, you can select various strategies, such as chip breaking or stock removal. You create the whole circle using the two circle and single positions position patterns. This work step completes the program. In any work step, it's possible to switch to the graphic view. To do this, select the Edit and Graphic View soft keys. A broken line drawing will be displayed. This representation allows you to very quickly compare the drawing with the program. Finally, the program is simulated. The 3D simulation displays the machining, including workpiece and tool, simultaneously alongside the program execution. This allows you to quickly find any collisions or program errors. The simulation provides additional views, such as 2D and a zoom or cuts. After the correct simulation, the program can be installed on the machine. And finally, a brief summary of the advantages of graphical programming. Intuitive program input, even without any DIN ISO knowledge. Linking of machining steps saves the multiple input of contours and position patterns. Time saving through complete program input via dialog box. All the information at a glance, including the tool and technology data, and simple input of the contour with the geometry processor, drawing dot to dot. Thank you for your interest in this video tutorial.